this is a dual bypass unloader. Its function is to act as a pressure relief valve with two means of bypassing the pressure out of the system. I was having some problems with the jetter, with it delivering inconsistent pressure, and with the essentially this pressure relief continuing to kick on and off. So I wanted to understand how this worked. So I broke it all down. I looked at some diagrams and schematics. Thought I'd make a quick video to hopefully explain this in an understandable manner to the next sucker in line. So the purpose of this is, like I said, it's a dual bypass unloader. So essentially what you'll have is flow coming in and flow coming out. So this is your inlet from your pump. This is your outlet to your gun or to your nozzle or to whatever you have your pump connected to. In an ideal world, you'll just have flow in and flow out. If you shut off your trigger on your pressure washer gun, or if you shut off your floor pedal for your jetter nozzle, or whatever you're using to control your flow rate, if you close it, you're going to have pressure building up in your system because your pump is still running. So when your pump is still running, it's going to keep trying to push pressure into the system. If you don't have any sort of relief built into that, which I hope everyone would understand this, but if you don't have any sort of relief built into that, your pressure in your line is going to keep building and make your pump work harder and harder until probably your pump is going to fail, because they have built-in weak spots, points of failure. So that way, if anything breaks, it's going to be this really maybe not easy to fix thing, but like this least disastrous thing to fix. Like, it's not going to create an explosion where you have some sort of piston shooting out and probably killing somebody. It's going to be like gears on or teeth on a gear that shear off. Function of this, how this works. I wanted to understand it, like I said, so I'll give you a quick breakdown. I say quick, it'll probably be about 10 minutes or so. So how do I want to tackle this? So as you can see, there's a ball inside of this. There is two chambers. Essentially, there's two primary chambers with two means of connecting them. You've got your inlet chamber and your outlet chamber. We'll call it that. Essentially what this will look like on most systems, and this is how you'll probably end up seeing it, is you'll probably be looking at it somewhat like this. You'll have an inlet and you'll have an outlet, and then one of these two on the outlet chamber is going to be the outlet. The other one is going to be the secondary bypass. So this ball is the primary bypass. This is where, when pressure builds up, this is the first place it's going to relieve to, and well, this will be your primary place of relief. There's also a secondary bypass because it's a dual bypass. What the dual bypass, or what the secondary bypass is used for in this instance, is for an easy start valve. I'll go into this component here in a bit. There's going to be three components that are breaking down. One of them is how this dual bypass works. The other one is how is this PA is the manufacturer. It's a PAES1 is the model. How this easy start valve works. The third thing that I'll break down is how this this is just essentially a pressure relief valve. I didn't understand how it worked when I took a look at it, but now I do, so I'll give you an understanding of that. This is a Giant 22533A, how this pressure relief valve works. So, pressure coming in, pressure going out. When pressure starts to build up in this line, how this whole device works is that you've got two means, like I said, of bypassing or relieving pressure. One of them is going to be out of this end and through this connection. This on our system, we have this and this bit here connected. So there's a hose that runs from here to here. So this is one of your bypass options, and then it's going to go out your outlet to your tank. Your secondary bypass option is right there with the ball, where it shoots through it and then goes out to your outlet tank. Now, as you can see, there's two springs here. You got a big spring inside of here, or sorry, you got a big spring out here, and you got a little spring inside of here. And both of them are on, both of these springs directly connect to this ball. So when you have pressure buildup in your system, and that ball is going to be closed when your pressure is building, you have this little tube right here that connects the inside of this portion of the device to your main chamber. And what that means is that you have a plunger, and you can kind of see it there, that conical shaped thing, that is directly connected to this ball. So when I push in this end of the rod, let me see if I can get a good angle here. So when I push in this end of the rod, you can see that plunger move. And as such, you can see that ball move. So that means that when this rod moves this way, it moves that bit and it moves that ball away from the face of this connection. That allows water to flow from here into this chamber and out your outlet, whatever side that is. For us, it's this one. So the way that water can do that and the way that the system works is that when pressure builds up in here, if you got a cutoff, flow will move through here and into a chamber in here and push this rod, and it basically pushes on the backside of this plunger and pushes that ball out, which then self-relieves pressure in the rest of that system. So for instance, water flowing through here, you got a cutoff, it'll flow up through here and build up pressure inside of here, which will push this plunger in and push that ball away from its seal that sits in between these two chambers and allow water into this outlet chamber and out. And like I said, you can see that ball move, and that's how that works. So what that means is that if you want to change the set amount of pressure that the system would need to achieve to relieve itself, you can do that. This is an adjustable pressure relief valve. If you tighten up these two nuts, so essentially if you compress the spring, or if you move the amount of rod that the spring is attached to, if you change the amount of rod that the spring is attached to via these two nuts, if you tighten it, essentially what you're saying is that you want more pressure in this whole system before it relieves. Typically you want to leave that at whatever the factory set it to. That's for good reason. Like we received a jetter trailer, so this whole thing was factory calibrated for the pressure that the pump and everything was set to. So I've already changed this because I was dumb and I didn't realize what I was doing, which is probably why I was having problems in the first place. So you probably don't really want to change this unless you know what you're doing and you are trying to achieve a set desired result. So tightening this up will increase the amount of pressure needed to actuate this rod and move that plunger. Loosening this up will lessen the amount of pressure needed to actuate that rod and relieve pressure. So that's how the, what is this, GP-2124 dual bypass unloader works. So this is the ES1 made by PA. This is an easy start valve. The way that this works is there's a little ball in here, and the way it works is one of two ways. And I'm not sure which one it is, and it doesn't really make a difference which way it works, but inside of this chamber, and you can see a little spring right there. So inside of this chamber is a spring and a ball. The way that I think it works, based off the diagrams that I was looking at, is that you have 2 points of contact that ball can seal to. It can seal to the front and it can seal to the back. So I believe that at no pressure, it's going to be sealing to the front. So from like 0 pressure to like, let's say like, I don't know, 5 PSI, that ball will be sealed up front. From like 5 PSI to let's say like 30 PSI, that spring will be compressed because pressure will be pushing in on that ball, but it won't be fully compressed. So you'll have the ball kind of free floating in the middle of this chamber with the water flowing around it out of this tube. And for us, it connects to this side of the outlet chamber, and then it'll be flowing out towards our tank again. And then at high pressure, the ball in here will be fully compressed, or the ball in here will be pushed all the way back and fully compressing the spring, which will seal again, which won't allow any flow through. So essentially, this only allows flow through this elbow when there's a, either when there's very little pressure in the system, like 0 to let's say 15 PSI or something, and that's just completely like I just pulled that out of my head. I don't know if that's actual number or not. So what the function is for is when the motor first starts up and it's turning the pump. If you don't have this on here, essentially you're just building pressure in a closed line unless you have the trigger on your gun open or unless you have the floor pedal actuated. You're going to be building pressure in the whole system. This is just meant to be a pressure relief at low pressures, so that way it makes it easier for the motor to start up without having a ton of load on it, because essentially you're trying to compress air, which okay, if there's fully water in here, then you're trying to compress an uncompressible. If there's air in here, then you're essentially trying to push in a spring that's going to be pretty tightly coiled, so it's not going to work very well. You'll have a lot of load on your motor, so to speak. Enough rambling. So that's those two components in conjunction. The third piece of our system So the way that we have this set up, and I've got this all flipped upside down and I apologize for that, but the way that we have this set up is that this is connected directly to a pump. This male joint goes into a female, what is that, 3/4 inch pipe thread, something like that, or 1/2 inch maybe, I don't know. Anyways, this is connected directly to our pump. This female has a tube running from it that connects to our inlet here. So you have pump side on this, runs through this, with this bit here, and I'll get into that, what that is, runs through there into our inlet and then out our outlet, you know, after all this happens. So what this is this is a pressure relief valve for high pressure. How this works is rather similar to this, this elbow here, but with a couple caveats. So you've got a very small entry point there for fluid, and like just looking at it, you wouldn't think that there's really an exit point, but that is the exit point. This is where water will come out when this pressure relief valve activates, essentially. So how this works is you have that right there is a set screw. The little hex, the Allen wrench head is a set screw. Inside of here, you have a spring and you've got a little piece of plastic, like you got a little plastic plunger. So when at low, you know, medium to high pressures even, depending on whatever this is set to, like let's say that this is set to 5,000 PSI. At 4,000 PSI, which I think is about what our pressure pump is rated for, or what it should be putting out, at 4,000 PSI, this should be closed. If it goes up to like 5,500 PSI and this is set to 5,000 PSI, this will open up. And the way that works is that pressure will come into this entry point, push on that little plastic plunger, which will push back the spring, which will push against this set screw. And essentially the plunger, which should be blocking this hole, will be opened and you'll have flow coming out of there. And we'll give you a good look at that. You can see the spring inside of there. So if you have water coming out of the end of this, the solution for this, if you haven't done, like if this came from factory, the solution for this is not to tighten that up, because depending on what it was set at, and you might want to, you know, talk to whoever made this, whoever assembled this whole thing for you, depending on what this is set at, if this is set to 5,000 PSI and your pressure pump is only supposed to be putting out 4,000 PSI and you got water coming out of here, that means that your whole system is putting out 5,000 pounds of pressure when it's only supposed to be putting out 4,000 pounds. So if you tighten that up, essentially what you're saying is, no, 5,000 pounds is not enough. I want you to put out 6,000 pounds of pressure before you start relieving. So that is not the solution. Don't tighten that up unless you know for a fact that it was not set right, or you're trying to achieve a desired result, that you know for a fact what that desired result would be. So in conjunction, you've got the way that our system works, and I'll show you on our jetter. So this is roughly what it would look like here. Motor turns the pump kicks out through our T, which has the high pressure relief valve. Then it flows from there into the inlet. Inlet comes through. If we've got a pressure blockage here, it'll bypass. Oop, I caught it. Wow, if I can get it threaded. Okay. It'll bypass through this tube, pushing this plunger in, which pushes on that, which opens up the ball valve, which allows flow through, out, and back into our tank. At low startup, or low pressures, you'll have this elbow open up and allow pressure through and bypass, and that's just to make the motor work less hard, which makes the pump work less hard because you have less pressure in the system and it's not building against anything. You're just letting it start up essentially. Once the pump actually starts putting out some pretty good pressure, this will close up and allow it to seal. I think that's it. I'll show you the quick diagram of how all this works together with a quick breakdown. I hope I answered anybody's questions, or if you guys are trying to figure out how this all works. So this is real rough and I apologize for it. So pump. This is the T that I was talking about that I just showed you. This is the pressure relief valve. We're using the Giant 22533A. You can see the outlet with the plunger, or with the set screw to the spring to the plunger. This is your inlet. Your inlet has three ways that the outlet can flow to. You can flow through the slow startup valve, but that'll only happen until set PSI. From there, it'll run back out into the bypass chamber, or into the outlet chamber. You've got your primary means of outlet to your nozzle. You've got your tertiary means, or you've got your tertiary outlet, which is just your secondary bypass. your primary bypass, which will flow out through here. And it can only do that when pressure is blocking here, coming up and into this chamber, pushing on this plunger, making it go forward, pushing that ball out and relieving pressure. Flow in your, so start to finish, flow comes through here. If you got a blockage here, it'll come up here and push this whole plunger assembly forward, which will mean that your flow or your pressure is relieved out into your tank. At low pressures, you'll have flow coming in. It'll hit your easy startup valve, come through, relieve until this closes, and then you'll have pressure building up. Essentially, if you tighten this, then it'll need more pressure for this whole thing to actuate. And you'll have just more pressure in your system. I don't recommend tightening that. I also don't recommend loosening it. I just say keep it at whatever the pump is set to. So, all right, best of luck.